Look at that, we're back. And we've got a keynote. This is our last keynote of the day from the folks at Confluent. I'm going to bring them onto the stage right now. Kasun and Yash, where you all at? Hey, wait, why are you guys all so small? Let's make you bigger, and let's get this guy out of here. How's it going, fellas?
It's going well.
Did you win some headphones?
No.
Not really.
Not this time, huh? All right. Well, you all have got to talk. I'm going to share your screen right now. It is on the stage. I'm going to get out of here, and I'll be back in about 15 minutes to ask you some questions.
Sounds good. Good evening, folks, and good afternoon, somebody. I'm Yashwanth. I'm a senior product marketing manager here at Confluent, and I'm joined by Kasun, who is a senior product manager at Confluent, and we're going to talk about simplifying streaming integrations with Confluent Tableflow, essentially from Kafka to open table formats such as Iceberg and Delta Lake. In case you haven't heard of Confluent, we are founded by the original creators of Apache Kafka, and we are happy to see that we are being used by 75% of the Fortune 500 companies. Just in case if you want to sign up for Confluent Cloud, explore the product and see its features and functionalities, please go ahead and scan the QR code and just get started today. We're giving $400 worth of free credits for the first 30 days of your usage. Before going deep into the topic, let's understand the context of operational and analytical divide historically. So, data across organizations is typically split across two estates, the operational estate and analytical estate. So operational estate is essentially all your operational apps such as SaaS, ERP, and so on and so forth. And Apache Kafka has become the de facto standard for organizing all the operational data, all the operational real-time data. And on the other side, we have analytical estate. And this is basically all the data lakes, data warehouses, and data lake houses. And if you look at it here, Apache Iceberg, Delta Lake, and even Hootie are becoming the standard open table formats for analytics. But converting that real-time Kafka streaming data into your data lake or your data warehouse, basically the analytical estate, is very painful and time-consuming. There's a lot of duplication, there are brittle pipelines, and then there's endless maintenance. Let's take a look at what it involves for converting Kafka topics into the open table formats that we are talking about. So there's this whole setup which you have to do to take out the Kafka streaming data out of your Kafka topics. It can be any of the connectors you want to use. It can be your own connector or the Confluence connector. And then you have your total ingest pipeline, which is basically converting Kafka topics into universally acceptable formats such as Parquet. And then there is schema evolution, type conversion, compaction, and so on and so forth. And then obviously syncing metadata into the catalog of your choice. And all of this is just to convert Kafka topics into raw formats or branch tables for that matter. And then you also have to do a lot of prep after the ingest stage, right? You have to do business specific rules and logic, the CDC metallization, deduplication, filtering, and so on and so forth to actually make the data ready for analytics. That is essentially converting that into silver and gold table formats. Here we go. We're introducing Tableflow, which basically represents Kafka topics as open table formats such as Apache Iceberg or Delta Lake in a few clicks to feed any data warehouse, data lake, or analytics engine. Imagine a solution which basically automates the entire ingest and prep process, which we have talked about earlier. So that's essentially what Tableflow is. And how does Tableflow do that? So before going a little bit, before going more into the topic, so we basically have something called Cora, which is basically a cloud native engine developed by Confluent, and we're using the storage layer of Cora to actually convert Kafka streams as tables, and then subsequently to Iceberg or Delta tables, and then storing it in either Confluent's managed storage or the storage of your choice. It can be as simple as an S3 bucket. Once that this is the automatic process I've been talking about. So all the prep process and all the ingest process, it's all automated by Tableflow. And once the Kafka topics are converted into Iceberg and Delta Lake tables, we can use any catalog sync of your choice. For example, AWS Glue, the inbuilt Iceberg REST catalog, Apache Polaris, or Databricks Unity catalog, so that you can feed the commercial data warehouses and data lakes such as OneHouse, Amazon Athena, Snowflake, Databricks, Starburst, and Dremio. Or this is also compatible with any third-party open source engine such as Spark, WebDB, Trino, and Imply. This is the entire process we have been talking about. So taking a Kafka topic, which is basically a real-time operational data, and then automating the entire process just few clicks, and then using the catalog of your own choice, and then accessing the data through any commercial or OSS third-party engines. Please take a note that the Unity catalog is coming soon, but trust everything is GA. And this is what our customers have been saying about Tableflow. Bussy is one of our early access customers, and they basically provide transportation solutions to businesses. And they're using Tableflow for real-time analytics using Apache Iceberg and Snowflake, and they see a lot of potential. And currently, they have been using this as part of their production real-time workloads, and they're also ensuring a more efficient and cost-effective data architecture. Here is a snapshot of all the Tableflow partners. We have commercial ecosystem partners, system integrators, and compatible technologies. And we are very happy to announce that OneHouse is one of our ecosystem partners, including Dremio and Prime Starburst, as well as the commercial partners such as AWS, Databricks, and Snowflake. And we have all the system integrators and compatible technologies that I've discussed earlier. With this, I would like to pass on this to Kasun, who will be walking through the functionalities of Tableflow, and then we'll walk you through the entire process of converting real-time operational data into open table formats such as Iceberg. Over to you.
Sure. Yes. Let me share my screen.
No, we don't see anything. You gotta try again.
Okay. Let me. How about now?
No. Still not seeing anything. There we go. Now I got it. But it's black. Hold on. What's going on here? Is this what you wanted to share? Hold on. There we go. All right. Here we go. Game on.
All right. Thank you. All right. So let me walk you through a quick demo of using Tableflow. As Josh mentioned, so it is a feature that is enabled in the Confluent Cloud. So here I have a Confluent Cloud Kafka cluster, and I have stored my streaming data in one of these topics. So I'm using this ODS topic, which I continuously ingest my streaming data to. And this is one of the sample event payloads. And so this is the Avro schema associated with the topic. So the destination table will be created based on the Avro. that you have here. Now, to enable table flow, it's you just need to click on enable table, and with that you have to table format. So we are currently supporting as a generally available feature and Delta Lake as so for this demo I'm using, and also you can select your storage option. You have the option of selecting custom storage or use Confluent managed storage, but for this demo I'm using custom storage. So since we are using custom storage, you need to also configure providers you to access from Confluent Cloud to your own S3 buckets. AWS assume roles and IAM policies, so you need to have them created in your account. So once you created the provider integration, you can also provide the S3 bucket name. So this is the storage that we will be using to store all your Iceberg tables. That you can review the default configuration and launch table flow. So that is all you have to do to connect an existing Kafka topic into an Iceberg table. It is automatically getting materialized into, and also table flow comes with a built-in Iceberg REST catalog. So you can the Iceberg REST catalog in the section of the topic. So this here you have the Iceberg REST catalog endpoint, and any Iceberg REST catalog embeddable engine. You can use, you can directly. Now for this demo, I'm using Amazon Athena PySpark, and I'm going to configure my notebook configuration to point to my Iceberg REST catalog endpoint, and also you need to obtain the required API and secret to access this REST catalog. So that can be done through Cloud Console. So after configuring everything, you can and then you are ready to start querying the topics or tables that we have just enabled table flow. Right. So for that, you need the cluster ID. So cluster ID directly maps to an Iceberg namespace. So therefore, you can navigate to your notebook and list all the tables that are part of this namespace. So here you can see this table or topic getting listed under the same namespace, and now you can start querying the orders table. Now, part of the table for materialization, it takes mapping, type mapping, that the covers it can also perform table maintenance as well. So garbage collection and all things are completely table flow. Now here you can view that we have seen from the Cloud Console earlier. Now, if you're not using Iceberg REST catalog, or if you have, or if you already have an Iceberg catalog such as AWS Glue that you're using with other data lakehouse project, you can also integrate with that. So to do that, you can create a catalog integration from your Kafka cluster level. So basically, Kafka cluster directly maps to a database in your Glue data catalog, and then a topic maps to a table in the Glue data catalog. So here I have already configured Glue data catalog integration for my Kafka cluster. Therefore, I should be able to discover these tables from my Glue data catalog. Let me navigate to the Glue data catalog, and under the table section, I can try to discover our orders table.
One thing, can you try to make it a little bit bigger?
Sure.
Thanks.
Okay. Now my orders topic resides in this cluster, and I should be able to map that here. And you view data, which will take you to the Athena. It will take you to the Athena SQL notebook. Now, in this case, we are using Athena. Athena is using Glue data catalog to connect to your Iceberg tables. So unlike the previous case where we connected directly to the Iceberg REST catalog. So therefore, any Glue compatible compute engine can start consuming data in this way. Now here we have the extension to the demo where we have one house which directly consumes this table catalog. To do that, we are first creating a new cluster in one house, and then this is the sample script that we are going to in one house, and this is the SPAGI point to the Iceberg REST catalog and point of table flow, and also provided the Iceberg REST catalog credentials. And as part of this script, we are the table that we have created, and also then convert it to a store in a separate S3 location. Now, to run this script, go back to the jobs section in one house, create a new job, and then select type as Python and to the cluster that we have just created, and also you need to point to the table flow Python script that I showed you earlier, and you can successfully create the job. And just go inside it and then execute it. Then you can view the status of the job execution. It is successfully executed and completed, and therefore you can go to the your workspace, and you should be able to new table created by this script. So basically, in this use Kafka topic, we loaded a Kafka topic to an Iceberg table, and then ran a query inside one house to convert it back another hoodie table. So you can basically include any processing logic as part of the script that I showed. That basically concludes the demo. Sure.
Sounds good. Thank you, Kasun, for such a nice demo. Okay, you can see your screen.
Yeah.
Sounds good. Thank you, Kasun, for such a nice demo. And in case if you just want to read and learn more about Confluent, we have a nice blog about Tableflow. And then we also have a very short explainer video on Tableflow on YouTube. And then please scan the QR images which is shown on the slide to just get started with Confluent Cloud. And also read and watch more about Tableflow in case you need any further information. Thank you so much.
Sweet, fellas. There's a lot of questions coming through, so I'm going to just start firing away. Correct me if I'm wrong here. If the ingestion rate is very high, we might end up with several small Parquet files. How is the compaction performed? Compaction, not sure if that's a word, but I like it. Is this something automatic or something the user would configure, i.e., compaction frequency? Is that a word that I just am not aware of? Or is that, it is a word, isn't it? They're using it like they're very confident it's a word. All right, so did you get that question?
Yeah. This is a question for real time. We are continuously it takes care of compacting all these data files. Use configurable. But we will optimize it based on all the parameters that we have internally, and create a compacted table for you, so you don't have anything or concept.
All right, your audio kind of broke up there, but it was basically like the compaction happens on your side of the fence, is what I understood.
Yeah, it's handled by it.
Excellent. All right, so when looking at Tableflow, how does it come from a streaming source like Confluent? I found Iceberg frequently chokes with my streaming use cases. Do you have plans to add hoodie as well, since we use some of both? There's a lot.
We are supposed to maybe in the future, based on the demand, we might also consider plans. We don't have hoodie.
All right, so right now, no, sorry, man, your audio is a little bit choppy, so I want to make sure that was clear. Right now, no, but if enough people ask for it in the future, yes, later.
Yeah.
All right, what is the current latency? This is where you get to show off some numbers.
So it depends on the so we are looking at for high volume data topic. If below what did you hear me properly?
All right, I think I got, basically it's, sorry, I'm just going to try and replay this back for you. It is potentially 15 minutes, but it all depends on the amount of data and the shape of the data and all that fun stuff. Yeah?
Correct.
All right, cool. Let's see if we can get you one. Yashwanth. We've got, folks would love to know what the GitHub URL is. And how does TableFlow for Delta Lake compare with Databricks DLT?
Yeah, so there are these are two options of creating data of a Kafka topic. So with the Confluent table for the Delta support, but Kafka topics into a Delta and Kafka infrastructure. But it is, and then that's another option as well. So there's it's completely up to the user to decide that. But if you are if you want to keep the direct parity between a Kafka topic and a table, Confluent might be the best option. But if you're already using DLTs and if that is more easier to use, then DLT would be the best option to convert a Kafka topic to a table.
Those headphones were messing you up. It sounded a lot better. It wasn't perfect, but that was a lot better. All right, I think we're getting pretty far here on this, on these questions that have been answered. Let me see. What capabilities would you highlight in TableFlow for analytical loads?
Yeah, again, the purpose of TableFlow is to create destination or target tables, right? And we try to optimize it for all the analytical works. Currently, something that we is partitioning. We plan to include in the upcoming releases. So keep optimize it for analytical workload with compaction and all the tech. At the same time, controllers like partitioning and various ways of optimizing these tables for your analytical workloads.
Excellent, fellas. All right. I think that's all we got, and we're going to keep cruising because there's still some conference left. We've got a few more talks to get through. This was wonderful. I want to give you all a huge shout out and really appreciate your participation in this. We're going to keep it moving. I've got some headphones to give away. I've also got a few more talks. So we'll see you all later. Thanks, fellas.